As usual, thank you very much to the FuturePrint team for putting these events on. They're always fantastic. It's good to see that we've got a huge turnout. Some of you probably know me. Those that don't, I'm the Commercial Director at Global Inkjet Systems. Some of you may know that we have, in fact, were recently, or about a year and a half ago, acquired by Nano Dimension. So I kind of play a couple of roles within the business. So both at Global Inkjet Systems, but I also play a significant role with a team called DeepCube. We have a team of about 30 to 40 people in AI and machine learning. And so you'll hear that through my presentation, some splatterings around that. We all know that, there's a lot of talk about AI and machine learning. We have a very high focus on machine learning, predictive modelling, and that we see that as a very important future. And we see that as a very integral part of this business, is around how you manage data from the digital printing area and how you use that to best optimise solutions. So my talk today is about how we can learn from horizontal innovation, which we heard from John earlier. So in fact, my presentation builds very nicely against that. And that is, how can we learn things from the automotive industry? The automotive industry is a very tight industry. It's an industry which has a very highly structured approach to the way in which it manufactures. And I'm going to sort of draw on that and show how I think that our industry could learn from that process. Look at some of the failings we have, in other words, why we don't necessarily succeed in getting forward as quickly as we could, and what we're doing about that to try to generate or create more of an environment which looks more like the automotive supply chain. The automotive industry is well known for having a massive number of parts, lots of OEMs, a tiered structure, a very complex supply chain in a lot of ways, yet they've achieved some very clever things, and that is the expectation, the potential for building a car and getting a bit that doesn't fit in it is very low. So when they get products into the factory and they assemble them, which most car manufacturers are purely assembly plants now, they don't produce, many of the subcomponents are pre-assembled for them, they generally fit. And I think that's quite an important message. So if you have a look at the general structure, I think we all know this kind of structure. You have the OEMs at the top end, the people that are putting it all together, making the thing that goes to the customer at the end of the day. You have your tier one supply chain with components and subcomponents. We have tier two, which are the enablers of the tier ones. Obviously, we're breaking things down into smaller pieces. And then we have tier three, which are the very raw material suppliers. And they tend to supply into both tier two and tier one, depending on what they are. If you look at how that looks directly with the automotive industry, you've got your final assemblies. Key assemblies such as putting engines together, putting the whole car together, getting the car out of the factory. On a tier one level, you have doors, bits and pieces, cockpits, dashboards, various components. I'm going to talk a little bit about customization in this as well, because I think that's an important facet of what's changing this industry and has an impact on the way in which this supply chain works. And obviously producing the complete assemblies. Then we have the tier twos, the raw materials, bits of glass, other things. In fact, in tier two also exist some of the smaller components like door handles, small radio elements, cabling, integrated circuits that go into the cars. And of course we have the tier three, which is the very sort of much smaller components in terms of cabling and things. Look at our industry. We have OEMs. Now there's two parts, I guess, two ways to look at this. We have, in the digital printing industry, we have companies which actually pretty much cover a lot of these tiers in-house, which is interesting. So they'll manufacture entire digital printing machines and a lot of the small components in some cases. Where we are at Global Inkjet Systems, of course, is quite different. We have over 150 customers globally. Each of those customers has something different. Each of those customers not only has something different for them, but they also make 2 or 3 variants of things. So we have some customers that make single pass and multi-pass printing machines. We have some customers which produce machines for multiple markets. We have some customers that actually produce machines for banner printing, but they also produce fabric printing machines. So it's a very complex structure that some of us actually live in. On the tier one, we've got integrators. There are a number of integrators globally. There seems to be less over time in our industry. In other words, people that might produce singular things that could be bolted onto a printing machine for hybrid printing presses, for example. But they certainly still exist. We have the tier two, which is really people making inspection systems, digital front ends, diagnostic tools, data path software, hardware, drive electronics, ink systems and the likes. And at the bottom end, we've got the more smaller components, which come from other industries. Encoders, product detect devices, scanners, linear slides, vibration sensors, all those sorts of things. But still, when you look at it this way, it's not much, there is somewhat of a tiered structure, but it's very loose. But I think there's a lot to be learnt, this whole idea of horizontal innovation, to learn from the automotive industry is how we could better align what we do with that type of approach. We see, in fact, in our market, we tend to get something that looks a bit more like this at the moment. OEMs and tier ones are kind of combined. They make the machines that they're going to sell out to the end users, but they also do a lot of the sub-component manufacturing. So that's also a common theme in terms of what we see in the industry. And then, of course, again, we have tier 2 and tier 3. But there's a lot of commonalities between our industry and the automotive industry. It can be a very complex supply chain. We've seen a lot of issues with supply in the last 3 years, particularly in the electronics component part of it. And us and our competitors, I think, have done a great job of working around that problem by looking at alternative components, not just alternative components as replacements for components, but actually redesigns to accommodate the fact the supply chain changed a lot in electronics. And that took a lot of innovation to move quickly to do that. And we see that also in the automotive industry. Complex, quick to move, that's something we need to get used to. We don't know whether next week or the week after a key component we need is integral in our products might actually be unavailable because our suppliers don't commit like they used to. Quality control is becoming more and more important. Customization is quite interesting. So, as I said, we have a lot of customers who have a very diverse range of requirements and they want to customize things. That causes a lot of chaos because every little change has to be recalculated. Everything has to be revisited. Simple things can change in a digital printing press in terms of design, and you need to redo things. Simply changing the way you screen an image changes the way you optimize it and can change the way you do other things. Choosing the wrong encoder or changing an encoder can change the whole nature of a printing device. So the customization has a lot of impact. Interesting enough, for the automotive industry, they're seeing customization in a different fashion in terms of people wanting to have bespoke cars. If you look at the SKUs on cars, the potential, a bit going back to the other presentation on packaging, you could have a massive number of options. Now they're looking at printing dashboards and how you print a dashboard, or printing the wing mirrors, or printing, not just printing to get lower cost and less loss through overspray, but also actual customization of the content on the car. Lots of technological advances going on in both of our industries over time. We're seeing environmental regulations, which I think is quite interesting. Obviously, in the automotive industry, there's a lot around regulations, emissions and things. In our industry, I think we're going to see more activity around managing energy and how that's done properly. So therefore, how do we not just have a printing press that consumes lots of power, which we don't have much control of, but how do we actually make printing presses where, in fact, the amount of energy is proportional to the image? The image content that you're printing should be something which is indicative of how much energy you're putting in the machine, from electronics, from curing systems, from UV lamps. They should all be segmented in a way you can actually manage the energy, and that will become, I think, an increasing pressure point. Lots of global competition. We obviously have competition in all sorts of places. We're seeing the Asian region with a lot more products coming out, copying products and things like this. And we've got things like the supply chain is becoming much more disruptive, I mentioned before, and we've got the distribution of the networks. But some of the trends are also similar. There's a high level of automation being adopted. We are now investing quite a lot of time into creating essentially digital twins of print heads. So when we do automated testing, we don't have to have a lot of print heads. We have something which electrically, functionally, measurably, metrics, looks like a print head. So when we put it through our QA, we can very quickly QA everything without having to actually stick it on a print head. And we have the data on the back end of that pseudo print head where we can get diagnostics from. And so that's a good example of the sorts of things we're investing in. Within Nano Dimensions, we're doing a lot more of those things. Nano Dimensions is a company which is investing into printed electronics, but not just printed electronics, automated pick and place of electronics. So we're talking about machines that can pick and place things into 3D printed circuits and printing 3D things around it. So it's not by chance they bought us. It was something which was quite targeted, and it's around this whole idea of having a high level of automation and technology to be able to assemble things quite quickly. We're also investing in robotics, machine learning, AI. Machine learning, I think, is very important. A number of the devices in the Nano Dimensions product range now, in fact, have quite strong machine learning and AI engines on them. They learn from what they printed, and they change what they're going to print next. And it's a dynamic thing, and that's where our DeepCube team comes into play. They built that engine, it goes up into the cloud, the data's done on a mass database, is then pushed down, and they accommodate those things that they learn in real time to change the way in which the printer works. And that's quite a profound change. It's had a massive impact on the yields on those machines. Sustainability I've mentioned before, reducing the cost of the carbon footprint through the process. This will be obviously something that's going to become quite important to us. And as I said, big data. I know there's a lot of talk about big data and cloud computing, and there's a lot of things how it can be used. We actually do use it in real practice. We have recently beta testing a technology which we put onto a printing machine. We're able to collect the data off that printing machine. It does get lifted into the cloud, and we do predictive modelling on it. So we're able to predict things like a filter might need to be changed based on the data on the machine, based on parameters which you wouldn't normally expect, but a machine learning engine doesn't care. So we don't have to tell it to look for X, Y, and Z. It says this is out of character. It seems to be coming from this data set. It could be something in these areas. It's probably this. And that's something we've started to beta test now, and next year you'll see a lot more of those sorts of things from Global Inkjet Systems, DeepCube, and Nano Dimensions as a whole. Just a brief comment on fragmentation. There's a lot of fragmentation in the component supply industry. Of course, the key thing for me is this last bullet point. And you hear me talk about this a lot in the industry. There needs to be a lot of collaboration. The more we know about what our customers are wanting to do in the future, the better. It's not about committing and saying we're going to hold you to it, but if we get a better feel for the types of volumes and expectations, we can build our supply chain and the volumes we purchase to manage that supply chain better, much, much better. So that's something we will endeavour to do a lot more in the future. So just in conclusion, there is competition across all sectors of the supply chain, but the good thing about our industry, it's got a massive amount of growth. So competition's good. There's plenty of space for competitors. There is a bit of a lack of cross-product integration, which we would like to see how we remedy. We have a focus on looking at how we can create more tiered structures with our partnerships. And you will see a lot more partnership approaches from Global Inkjet Systems. We're forming more and more and more in some unusual places. So at the end of this month, you hopefully will hear about some more of those integrations and partnerships we've got. And I will, in fact, be giving a presentation at the end of the month, which is much more focused on a very definitive view of how AI and machine learning can help this industry. But that's for that time. And so in conclusion, I think there's a lot of things we can learn from other industries. I think there's a lot of innovation we can learn. If we all take the time to do it, it would be massively important. And the automotive industry seems to be a pretty good one to look at. So thank you.